Hi, I'm Arafa Farahmandi, Master Student of Electrical Engineering at University of Tehran. Let me share my screen to start our discussion. Yes, first of all, we set up Python package and load data for starting at our work. And we wanted to investigate whether the neural activity is explained by mouse behavior or not. So after loading the data, I wanted to split the data into train and test data. The necessity of this work is to prevent overfitting. Overfitting is making a model that matches so closely with our trained data, but fail to work and make a correct prediction with any other new data. So we should train our model with our data, but validate it with another new data to be sure that it's not overfitting. Okay, I split them. And after plotting, yes, you see that we have a separate chunk of data. They are separately because we wanted to prevent the correlation between neural data input at time. So after that, we wanted to go to linear regression. Linear regression has a weight matrix that is the multiplying two inputs to access our output. The weight matrix is calculated from this formula. It's due to the least square method. It's multiplying two matrices. The first one is covariance matrix of inputs data, and also we calculate the inverse of this matrix, and this is the covariance matrix between x and y. So I can calculate it, and I can write this for you, for example, and y hat linear, it is a test index of input, yes, and I can run this for you. After that, I wanted to plot it to show the output of our model. The green one is the output of our model, and the black one is the real data. As you see, with getting high PC, we can see that from this point, we have injecting more variance than the first seconds. So it shows us that we have some problem, and here we inject a lot of variance to our model. So we use a ridge regression to investigate this problem. Okay, here we have a regulation term that added to covariance matrix. It is multiplying a scalar lambda to with identity matrix. And I wanted to say that covariance matrix in some time maybe it will be ill condition, and we have some singularity problem with this matrix. By adding this term, we can prevent this problem too. And here I wanted to choose lambda, and yes, okay, and I wanted to calculate it, and after that I plot it to see you the result. And as you see, please look at this figure and to see that by getting high and high PC, we can see that the variance is little and little, and it is near to zero. That's really good. For comparing, I can plot in trained data. As you see, the green one is fitting more, much better, but this is just overfitting, because in test data you can see that variance is decreasing in orange one. Overfitting means that just our model memorize the data, the trained data, and it's not our purpose. We wanted to model every data. Okay, that's it.